Hey guys, this is Eric Weingartner with Weingartner Racing. It is another video for you guys today. For those that are new to the channel, on Wednesdays I typically do a product review video, and this week it actually happens to be over one of my heads that I just finished sporting. But anyway, before I do that, I want to talk about something I mentioned on Sunday's video, which was I told what I was going to do was, and please pay attention to this part because I really want as much audience involvement as possible. But what I'm going to do is I'm going to get an LS3 head, and it looks like right now I'm going to get the Flowtech head from Summit, and the reason why is because it's cheap and it's available. And what I'm going to do is I'm going to let you guys decide every aspect of the head. And several people wanted it dimpled, so probably the first thing I'll do is actually flow it just as it comes out of the box, and then I'll do some dimpling and then different things along the way. So what I'm going to do is I'll give you guys different options of what I can do for a valve job, different options for how large you want to make the bowl, how big you want to make the throat, and each time I'll flow it and you'll get to see the results. And this will be kind of a consensus from what you guys want to see, and that's how it'll be. Now, someone had said, why don't you port one exactly the way you would do it, and we could see how it compares. I will actually do that. I'll port one hole, and that gives you 3 more options to choose from. And we can get as crazy or as not as you want to, because the head will never be on an engine. It's just something to see what happens. So if we want to do something extremely rare, weird, or if it breaks through water, no big deal. So anyway, that's that. So if you can, put comments about that. I'm going to try to order the head tonight, maybe. We'll see. But anyway, today's video is about my Brodix Dragon Slayer. Yes, another one. But this one's my Dragon Slayer. It's the 248X, and I'll tell you about the differences. For those that don't know, I do a ton of Dragon Slayers. This one's finished. This is unfinished. We'll use it for demonstration purposes. Now, I've done several different things with the Dragon Slayers, and I'll just give you a rundown of some of them, and I'll talk about this one and show you some pretty cool stuff that goes with it. Also some stuff, of course, to teach you, because I'm not just trying to sell heads or nothing. I'm busy enough, but I want to give you information. So the heads are available as like intake valve sizes. I've gone from 208 all the way up to 218. Exhaust valves gone from 155 all the way to 16. I don't really go bigger. Port volumes have gone from the smallest one I offer is a 235 all the way up to the large one's 265 cc's, which is big. We've done different valve spacing. So this one is a 40-60. This one's a standard. Different size guides, different size chambers. Chambers are down to 58 cc's is the smallest I've gone. Push rod pinches different locations too. So I've made the head cross section at the push rod pinch in different sizes. And each time I try something, I try to do something a little different each year just to see what happens. And sometimes in between. Now, some of you say, well, you port so many of them, why don't you have a CNC program? The reason why is because there are so many different ways in which I do this head. I think I offer like 5 or 6 different versions of this one alone. So, and the reason why is because each one's a little different. And by the way, yes, these are engraved, but if you ever got the older ones, they'll just have the Brodix logo, and I sign them, and I put a date. The date will let me tell how far, what port work or port version that is. Because there's earlier versions, I did different things than I do now. And years from now, I might be doing something different than I'm doing now as well. So, but anyway, let's get started with this head. This one's a 248X, and you're like, what's that mean? Well, it's 248 cc's. And what I've done is I had to move the valve spacing. So instead of it being a standard valve spacing, because the Dragon Slayer is a standard valve spacing head, it's really good head. But this one's not. This one I had to move this valve spacing, and I will show some cool flow numbers in relation with that. But the intake valves moved over 40 thousandths, the exhaust valves moved over 60. So the exhaust valve is actually closer to the cylinder wall, and the intake valve is further over. Because of that, I could put a bigger intake valve. So it has a 2125 by a 1600. Because usually on my standard version, I can do a 2125, but I have to do a smaller exhaust valve because of the bigger intake valve. You have to have a certain amount of clearance in between the two. And since this one's got the moved center lines, because the valves are moved over, there's more of a gap in between, hence I could put bigger valve. That's why I love Brodix having these bigger seats in here, because I could put a pretty large valve in this and still never have to change the seats. So anyway, that's one thing. Now this one's a bit different than the other ones you've seen before in the previous videos, because you could tell by this is the push rod slot. It's a standard push rod slot. This one does not have the wing. The wing was that little vein you saw in the center. This does not. So let me get a light and I'll try to show you, and I'll stop the video and I'll get a light and show a better view. Okay, there you can get a view down the port. Now this has a 1206 entry. I can go bigger, but we'll talk about it in a minute. But this is a 1206 entry, and at the push rod pinch, the area is 2.65. I used to actually have it at 2.71 because when I first had them do this, they actually moved the slot over a little bit, and I don't know why, but Brodix changed the way they machine their slots. There's not as much material. So currently there's 60 thousandths in material between here and where the end, in other words, between the outside here and the inside here is 60 thousandths. I've measured it on all of them. But I used to have more material so I could move this over more and have a bigger area at the push rod pinch. Now I use Wallace Racing Calculator for the minimum cross-sectional area. And this one, if you're just using that, the 2.65 will peak about 7,000 RPM on a 400 and about 6,800 on a 434, around that in the ballpark figures. 2.65 here, but so that I will say and I didn't measure velocities, and I know everybody wants to ask that. I rarely actually measure velocities. I do so much of these, I really, as long as I know what the area is when I'm porting, I kind of have an idea what's going to happen. But I will say the velocities are pretty fast through these anyway, because there's so much area here and amount of air that's moving. And I'll show you that in a minute. Now there's that. It's a good head, and it doesn't require shaft rockers, because this one, because the push rod slots are where they are, the rockers will take stud mount rockers. So that's a plus. You don't have to have an expensive shaft rocker set up for this. So if you're looking for a stud mount system where I don't have to buy shaft rockers, what's the best one you could do that doesn't require shaft rockers? It's actually this one. This is the best one that doesn't require shaft rockers. Now, I have several versions, of course, that do require shaft rockers, but shaft rockers typically run about $1,500 to $1,600 for the ones that you need for this. You can't use the Sportsman ones when I move the push rod slot over. There's not enough, they don't offer enough offset for that. So you have to get the more expensive shaft rockers for my offset versions. This one doesn't require it. Stud mounts work perfect. So I've got a similar version of this called my 242, which takes stud mount rockers, but it's standard valve spacing. This one's better than it. So just letting you know. Now, I'm not going to say it's the baddest in the world, because I really hate when people say the baddest. Well, you might have been that head might be on a great engine, but another head might be great on it too, or better. They just never tested it, because a lot of people, once they got a good combination, they don't change things too much. So it's not like I switch the whole cylinder heads, because it means different pistons and everything else. So I'm not going to say it's the baddest, but it's pretty bad. It's pretty bad for a stud mount rocker setup. So I want to point that out. Anyway, if you want results, because if you look at my website, I have a quote from Richard Marcinko, and it says, "Seek results, not excuses." On this head, I've done a couple sets. One dynoed at 740 horsepower. So that's pretty good. And that was on a 406. Very proud of that. My standard ones, and I've done way more of the standard version of this, where it's not moved center lines. It typically is about 700 horsepower. These are about 20 horsepower better with the move center line. That's from everything I've seen. And I've got several customers I could tell you. I just don't like bragging it up, because that's just telling you information. If you ask, I can tell you how much power it is, but there's no sense in me just telling you every customer and how much power they make and just putting it out there. I'd rather be humble. So it's easier for a customer to tell than it is for me to tell. So I'll put it to you that way. So anyway, these will make about 720. The standard version makes about 700. They really can't make that much more unless you do different things with the cam because of the push rod slot. That's really the limiting factor. So having the stud mount rockers does limit your power potential just because of the push rod pinch. Now, I do want to say, on a coming up version I'm getting ready to try, and I've done this once before, but I wasn't super happy with the results, but I'm going to revisit it. What I am going to do on the next version, which is this one here, that one's standard valve spacing. What I'm going to do, instead of having it at 1206, I'm going to have it 1206 wide, but 1207 tall. So it's kind of in between. This should give me more area here at the push rod slot. Now, I've done it before, and it didn't seem like it gained anything on the customers I had done it for. So it wasn't any faster than exactly like I had done here, even though I had more area at the pinch. and that was on a 434. I would have thought it would have gained more, but it didn't gain anything more than it did. It performed almost exactly like it does like this. So it was kind of a letdown. I will say when you raise it up, the biggest thing is getting an intake to fit. Since I'm porting an intake for that one to match it, I shouldn't have to worry about that. I know I can get it to work with it. But this one's a 1206. Every one of mine are a 1206. So unless I do one of the bigger ones, like a 265. But anyway, that's the head. Let's look at the numbers. Now I have 2 flow benches, but I'll show you both of them. And then I show you some really cool stuff to give you a little something to think about. I promise. So this is from the Sanyez. This is a 4155 bore. The numbers I care most about are at 4, 6, and peak. And I know, which is at 1. I know someone's going to say, well, no one has a cam of 1 inch. People do, but maybe not this customer, I could tell you. But it just tells me how stable the port is. So if I look at 4, 256, that's a really good number there. And then if I look at 6, it's 321. That's a really good number. Really good number at 6. And at peak number, it's 334. Now, the exhaust is a little bit, this one's I want to talk about. And I'm getting ready to compare the two, but if you look at this head and the amount of air that it flows because of the moved center line, I will tell you this. Because the exhaust was moved closer to the cylinder wall, the exhaust flows worse. So yes, the intake's better, but the exhaust flows a little bit worse. And really, it gets, if I compare it to my regular 242 with the standard valve spacing, the exhaust will flow better on the regular valve spacing until about 500. Then they're the same. But this is about 10 CFM less than normal. That's about 10 less. That's about 5, and that's about 5. So having the exhaust valve close to the cylinder wall really hurts the low lift flows. And I mean low all the way to about 500 lift on this head. Just giving you an idea. But it definitely helps on the intake side. So anyway, there's that. But let's look at the Superflow, because everybody posts the Superflow numbers because everybody's so proud of those. So I do have a Superflow, and I'll show you those because it's, of course, better. These are the Superflow numbers. So now if I look at my number at 4, it's 267. Really good. At 6, 329. Almost 330 CFM at 600. And at peak, 344. So the same head, just took it off one bench, put it on the other one. The only reason why I'm showing you this is because a lot of people use Superflow numbers. I'm just showing you. The exhaust using on the Superflow is a little bit worse, which it is by a few CFM, but it follows the same trend. Now, as cool as that is, I want to show you this. This is what I was trying to get to. Out of my own curiosity, I pulled up a report that my flow bench can do, and what it can do is it can tell me the differences between heads. It can compare heads. So what I've got here on this column is my regular 242, and these are both flowed on the Superflow. So this is my regular 242 standard valve spacing 210 intake valve versus this head that I'm talking about today, which is my 248X. So you have a 210 versus a 2125, and then we'll look at the flow numbers and see how they differ. And this will tell me the difference. So this is my regular 242, and I'm only going to do the intake flow. This is the regular 242. This is the 248X. And this tells you how much you're gaining as far as flow from the bigger valve and the moved over center line. So gains are pretty good. It's, I'd say, about an average of 7. That's a nice gain. And look, 2.5%, 3.2 there, 3.8 there. So pretty good gains, really good gain just from the moved center line and the bigger valve. Because as far as the sizing inside the port, it's pretty much identical. Okay, now there's one other cool thing I want to show you because this deals with this. This one is the velocities. Now this is the average port velocity, and this is calculated. This is not measured with my pitot tube. Okay, so this is the 242 standard, and this is the one with the moved center line. So we look at our average velocities. At peak, this is interesting, it's only slightly better, 0.3% increase in speed. But if you look at the rest, the average velocity, of course, increases because if you're moving more air through about the same size port, because they're pretty close to the same size, your airspeed is going to pick up. And it does by a few percent. And you look here at 2.1% and how much actual airspeed it's picked up. Now, in general, 285 average airspeed is pretty good. And it gets to 287 and look at 700 lift. By the way, this guy's actually running a 700 lift. And I could go, had some more people comment on that. If you run a 700 lift, you know how much duration you have at 700? 0. Because it's just going to touch 700 to go back down. 0 degrees of crankshaft rotation. So most of your stuff will actually be below that. This is the reason why I really like and emphasize having higher lifts. Because if I had, like, say, an 800 lift cam, I would then see more of the time here at these lower lifts, like 6 or 7. So if you had an 800 lift cam, you're going to see more of the 700 number than you would if you just had a 700 lift cam. But anyway, this kind of gives you some more information. This gives you something to think about anyway. Feel free to use this however you want. Both these heads are the same stem diameter too. And it says seat angle on the exhaust. You can ignore the exhaust because the exhaust isn't on here. So these are just the intake velocities. So hopefully it gives you something to think about. All right, I appreciate you guys watching. Please tune back in on Friday. I'm gonna do some more racing stuff. The truck's actually able to start up. You'll get to hear that. I actually really wanna ask you a question because the Throwdown in T-Town, which is a major race in Tulsa, is next week. And I'm going to drag out the Camaro and I'll probably get beat in either class, but I wanna ask you guys what class I should enter. Anyway, feel free to tune in on Friday where I will talk some more about that, some racing stuff. And Sunday's video, I haven't yet decided, but I'm thinking about hopefully if the LS head's here, I can start doing some of that because the first thing I'll try is flowing it and then dimpling it. So if shipping's good, maybe you'll see those results on Sunday. Anyway, make sure you share this video just because I do want to make more money, but the biggest reason is I need more input on the LS head. Otherwise, it'll be pretty boring with nobody responding except for the one guy who's got some oddball request. Anyway, you guys take care and thanks for watching.